Hello students, today again I am here to discuss one misconception in chemistry, and today's topic on misconception is how does halogen acts as electrophile in electrophilic aromatic substitution reaction. So this question has been given to the students. The question is that the reaction of toluene with chlorine in presence of ferric chloride gives X and the reaction in presence of light gives Y. Then what are the X and Y? So there are four options has been given. So now what is the answer? The first reaction where toluene reacts with chlorine in presence of ferric chloride. Here we get a mixture of product orthochlorotoluene and parachlorotoluene, and it follows the electrophilic aromatic substitution reaction. And we all know that methyl is an electron donating group, so it's a ortho-para director. Now in the second reaction condition, where toluene is reacted with chlorine in presence of sunlight, it follows a different reaction mechanism. It follows the free radical reaction mechanism. So that's why the step-by-step reaction happens. First, one hydrogen gets replaced with chlorine radical. Then it becomes CH2Cl. Then the next hydrogen, CHCl2. Then finally the last hydrogen, and we are getting CCl3. So that is trichloromethyl benzene. So now you can see in this question, the correct answer, the X is the mixture of orthochlorotoluene and parachlorotoluene, and Y is the trichloromethyl benzene. So that means in the first reaction, as I already mentioned, that it follows the electrophilic aromatic substitution reaction, and here chlorine molecule reacts as electrophile. It forms Cl plus as electrophile. Now aromatic ring is electron rich system, so it attacks the electrophile, then it follows the electrophilic aromatic substitution reaction, and it gives the mixture of product orthochlorotoluene and parachlorotoluene. Now let's see what is the misconception from the student. So this is the answer was provided by one of the student. So here you can see, instead of chlorine, Cl2 get attached. So that is the misconception. So to clarify this misconception, students should understand the formation of electrophile, like from the chlorine molecule, how you are getting Cl plus, and that is acting as a electrophile. So now here you can see this is a chlorine molecule and this is ferric chloride molecule. Now chlorine molecule is a nonpolar molecule, and here you can see that each chlorine is sharing one electron, and then it forms a sigma bond, and each chlorine has 3 lone pairs. And ferric chloride, in ferric chloride, iron having 3d orbital, vacant 3d orbital. So chlorine extra lone pair can be donated to the ferric chloride, and then this kind of this is called Lewis acid base adduct, because ferric chloride is accepting the electron, so it is acting as a Lewis acid. Now chlorine molecule is donating 1 electron to the ferric chloride, so here chlorine molecule is acting like a Lewis base. So this kind of formation is called the Lewis acid base adduct. Now here you can see, due to this formation of this bond, now chlorine molecules are getting polarity. So initially, as I told, chlorine molecule is non-polar because there is no electronegativity difference between these two atoms. But now due to formation of Lewis acid base adduct, now one chlorine is getting delta positive charge, and then finally this bond breaks, and then we are getting Cl plus electrophile. Now this Cl plus electrophile acts as a electrophile and attack to the aromatic system in toluene. Now let's see exactly how this is happening, means what is the reaction mechanism of electrophilic aromatic substitution reaction. Now as we already mentioned that methyl is an electron donating group, so it's an ortho para director. So now let's see first that how the ortho attack happens. So when the ortho attack happens, the double bond, that pi cloud, attacks to the Cl plus, which acts as electrophile, and we are getting this intermediate, the carbocation. Now what happens? It will undergoes resonance, then finally the deprotonation, and we will be getting the orthochlorotoluene. Similarly, when the para attacks takes place, so that time this double bond attacks to the electrophile Cl plus, and we get this intermediate. Then again the resonance takes place, then the deprotonation happen, and then finally we are getting the parachlorotoluene. So I think from this explanation students have understood that how chlorine molecule breaks into Cl plus electrophile, and that Cl plus electrophile is get attacked by the aromatic system of toluene. So this is orthochlorotoluene and the parachlorotoluene. So the molecule, the atoms which is going to attach with the aromatic system for the halogenation reaction, that is the Cl, not the Cl2. So I think now the misconception has clarified. So whenever you have such misconception in chemistry, always try to clarify all those misconceptions, because misconception is the barriers to understand the science. So if you have any chemistry related queries, write email to chemistry.affinity@gmail.com. Thank you for watching.